R32 versus R410A, a clash of refrigerant gases. Welcome to this exciting video where we will compare two refrigerant gases, R32 and R410A. Which one will come out on top? Let's find out together. Break time equals 2's, greater than. Let's begin by stating that R410A is a blend of two gases, while 32 South African Rand is a pure gas composed of a single component. Break time equals 2's, greater than. R410A is primarily composed of R32 and R125, with a 50% proportion for each component. On the other hand, R32, being a pure gas, can be charged in both liquid and gaseous phases, whereas R410A, being formed by two gases, must be recharged exclusively in the liquid phase. Break time equals 2's, greater than. Both refrigerant gases, R32 and R410A, work with PO-type oil. However, due to the presence of R125 within R410A, the latter exhibits better miscibility with PO oil compared to R32. Break time equals 2's, greater than. This means that R410A blends more easily, favoring the return of PO oil to the compressor in the refrigeration system. Consequently, in many compressors using R32, the PO oil operates at a lower viscosity compared to when it works with R410A. Break time equals 2's, greater than. R32 has a higher temperature at the compressor outlet compared to R410A, making it crucial to work with PO oils with a high viscosity index in the presence of R32. This ensures that viscosity remains more stable when temperature changes. Break time equals 2's, greater than. But let's now talk about performance. R32 has a greater cooling power compared to R410A, as well as in heating. This means that a lesser amount of gas is needed to achieve the same level of cooling and heating. Break time equals 2's, greater than. Additionally, it is important to consider the environmental impact. The global warming potential, GWP, of R410A is 2085, while the GWP of 32 South African Rand is 675. This indicates that R32 has a smaller environmental footprint in terms of greenhouse gas emissions. Break time equals 2's, greater than. Now, let's discuss safety. Although R32 is flammable, its flammability level is low compared to hydrocarbon refrigerants like propane. Therefore, R32 is positioned as a slightly flammable refrigerant, maintaining high safety standards. Break time equals 2's, greater than. In summary, R32 stands out as a more efficient refrigerant gas in both cooling and heating compared to R410A. Its lower GWP and controlled flammability make it an attractive option for air conditioning systems. Due to the lower miscibility of R32 with PO oil, compared to R410A, it is highly recommended to strictly follow the installation recommendations provided by the equipment manufacturer to ensure proper oil return to the compressor.
As the miscibility of R32 with PO oil is less compared to R410A, it is highly recommended to strictly follow the installation recommendations of the equipment manufacturer, in order to never affect the return of the oil to the compressor. On the screen we have the table of pressure and temperature of the refrigerant gas R410A. Although the table shows us two pressures, one for dew and the other for steam, since the sliding of this gas is very low, the difference between both pressure values is negligible. In this case we are going to work with the vapor pressure. For an evaporator temperature of 5 degrees C or 41 degrees F, typical of an air conditioner, the gauge pressure at this point is required to be 8.27 bars or 121.63 psi. For an outdoor environment temperature of 30 degrees Celsius or 86 degrees Fahrenheit, and considering that the condenser temperature on average exceeds the ambient value by 10 degrees C, then the condenser temperature is 40 degrees C or 104 degrees F. Looking in the table, for this temperature value, the condenser pressure, or high, has a value of 22.63 bars or 332.75 psi. When it is necessary to know the pressure of the equipment when it is turned off with the value of the outside temperature, the pressure value is searched in the table. In this way for 30 degrees Celsius or 86 degrees Fahrenheit. According to the table, the equipment pressure at rest is 17.50 bar or 257.28 psi.
For an evaporator temperature of 5 degrees C, the pressure gauge on an R32 air conditioner should read about 129 psi. The high pressure of an air conditioner that works with R32 for an outdoor ambient temperature of 30 degrees Celsius should mark close to 350 psi.
And there you have it. The battle between the R32 and R410 comes to an end. Now it is your turn to decide which of these refrigerant gases best suits your needs. Leave us your comments and subscribe to our channel.